All right, so I wanted to just use this problem as an example of how to find the area between two curves. I think once you see the method, I think it'll make sense to you, but if you need more help, we can also look at some other ones. So I chose this one that you sent me a picture of, and so the two curves that we're asked about is y equals 3 over x, y equals 3 over x squared, and then x equals 7. And you can see right here that this is ending at x equals 7. And in terms of which curve is in the top or the bottom, because you have 3 over x squared, because that'll give you a bigger denominator, so it's going to drop off a lot quicker, so that one's going to be your bottom curve, and the 3 over x is going to be your top curve. And that's going to be something that we're going to use that information in a little bit. But the other thing that I wanted to do before I went into the integration was I wanted to figure out like what this point is right here, because in a sense we're going to be integrating over x, and we're going to start at this point and we're going to end here. And so I wanted to know what that ending point is. The beginning point. The ending point was obvious. It was x equals 7. That's what they gave you. And so in order to figure out what this was, I wanted to answer the question, where did the two curves intersect? So I set them equal to each other, because then if they have the same y value, we'll find the x where they have the same y value. So I set them equal to each other, and I ended up finding there's two values where they're going to intersect. I think you can see this will go back, but the 0 doesn't really make any sense. But anyway, we see that they intersect at x equals 1. Okay, so that's information for us, because for us our integration is going to go from x equals 1 to x equals 7. So let's talk about what exactly we're doing, the general process of finding the area. Finding the area through calculus is basically taking little pieces that have a small amount of area and adding them all up through integration. This red thing that they're showing right here, which I just colored blue, is your little strip that represents your area dA. And in this particular problem, it's vertical. So let's go next slide. So our dA is a rectangle, so its area is its height times its width. Now the width is just dx, because that's just going from here to here, this little piece, and so that's our dx, and that's how we're going to get something to integrate. The height is the top minus the bottom, and so that's the top curve minus the bottom curve is going to be the total height. Or we might say y top minus y bottom times dx. And that's the reason that I wanted to know which curve was on the top. So if you remember, this is y equals 3 over x, and this one is y equals 3 over x squared. So finding our area is integrating all the little dA's, and now we've said, well, I should write this, substitute in what the y top and the y bottom is, and so it's 3 over x minus 3 over x squared. That's the y top minus the y bottom times dx. And so I got 3 over x minus 3 over x squared dx, and goes from 1 to 7, because that's the x values where I start and where I end. So this gives you a natural log. I don't really like that, but what are you going to do? So the area is 3 times the natural log of x evaluated at 1 and 7 minus 3 over x, and then times a negative 1, evaluated at 1 and 7. So it's 3 natural log of x, evaluated at 1 and 7, plus 3 over x, evaluated at 1 and 7. And this should give you the area. Really, really hope so, because that's how you do it. So basically, I kind of looked through your problems. It seems like a lot of these are just doing this method. You take a little strip, you see how high it is, you just think of it as a rectangle. In one direction, it's going to have it's either, if it's a vertical strip, its width will be dx, and then the height you find by the difference between the two y values of the two curves. If it's a horizontal strip, you're going to have the height of the strip is going to be dy, and then you subtract the two x values to get the width of it. I'm going to look at some of the other problems to see if you have some other things that you're working on. That whole triangle one would be a lot harder because you're going to have to make, I'm not sure, like you'd have to have the equations of the lines, and you're going to have different lines. So we'll save that for later.